Welcome back to the workshop for one last video in section 2.6, applications. We want to look at just one more example. It has a few parts, but it's a relatively simple example. So at Avanti's, a pizza can be ordered with any combination of the following ingredients. Combination, man, sounds familiar. I think I said that word a little while ago in a previous video. At Avanti's, a pizza can be ordered with any combination of the ingredients: green pepper, ham, hamburger, mushrooms, onion, pepperoni, and sausage. All right, how many different pizzas can be ordered? Well, we're trying to keep things a little bit simple here, so we're not talking about double cheese, we're not talking about double green pepper, double onion, double mushrooms, whatever. Okay, just single toppings. How many different pizzas can be ordered? Well, what we can recognize is that a different pizza is given by different selections of the toppings that can go on it. And if that's the case, we're just seeing how many different ways we can choose some toppings. So how many different ways can we choose toppings? Well, how many subsets of the toppings are there, right? If one selection, one choice of toppings is a subset, then we're just looking for all the possible subsets. So how many subsets of the toppings? That's the question that we need to answer. Well, there's 1, 2, 3, 4, 5, 6, 7 toppings. So 7 toppings. So there's 2 to the 7th, which is 128 possible pizzas. Excellent. So there's 128 different pizzas that can be ordered. Let's refine this a little bit. How many different pizzas can be ordered with exactly 3 toppings? Well, this goes back to the combinations. This goes back to 7 items, choose 3 of them. I don't care what order they are chosen in. We're just choosing 3 of them. Ham, hamburger, and pepperoni. That sounds pretty good to me. Doesn't matter that I chose ham, hamburger, pepperoni. I could have chosen pepperoni, hamburger, ham. No worries. It's still the same 3 items. So when order doesn't matter, we use the idea of combinations. So we want to choose from 7 items, 3 of them. 7 choose 3. Combinations of 3 items from 7. Okay, different ways to say it. So that's 7 factorial divided by 7 minus 3 factorial times 3 factorial. So that's 7 factorial divided by 4 factorial times 3 factorial. There's some reducing here. So 7 times 6 times 5. The 4 factorial cancels out with the 4 factorial, and we're just left with 3 times 2 times 1. 3 times 2 is 6, so we just have 7 times 5, which is 35. So 35 different pizzas with 3 toppings. Excellent, easy enough. So how many different pizzas can be ordered with up to 3 toppings? So we've slightly adjusted the problem one more time. How many ways can we choose, can we order a pizza with 3 toppings? So what we're saying here is we have 7 possible toppings that we can put on the pizza. We can choose up to 3. Well, what does it mean to choose up to 3? Well, I could choose 0, or I could choose 1, or I could choose 2, or I could choose 3. Well, there's only one way to choose 0 items, and that's to choose 0 of them. So one way to choose 0 from 7. How many ways can I choose 1 thing from 7? Well, there's 7 ways, right? Any one of the individual toppings. So 7 choose 1 is 7. 7 choose 2 is a little bit more complicated at 7 factorial divided by 5 factorial times 2 factorial. And 7 choose 3 we already calculated to be 35. All right, so 35 plus 8 is 43. 7 factorial divided by 5 factorial is just 7 times 6. 2 factorial is just 2. So 6 divided by 2 is 3. 7 times 3 is 21. So 43 plus 21 gives us 64 different pizzas with up to 3 toppings. So it's just a few more examples in counting. But that's the last example. That's it. End of the section. So thank you for your time and your attention. I'll see you guys again soon back here in the workshop when we move on to our next section.